Greetings to all. This is Ranjini working as an assistant professor in the Department of Computer Science and Engineering at RMD Engineering College. In this lecture, let's see about the implementation part of the stack using an array. So the first operation we perform here is a push operation. We are going to look at the push operation. So hash defined n is equal to 5, which means I'm defining the size of n size is 5. So which means into the main function I'll initialize declare this arrays to be a stack of n. So stack of 5, which means the size of my stack is 5. So int top is equal to -1. Initially the top value will be -1. So now let's enter into the push function. First, if you want to insert an element into the stack, means what we have to check for is the overflow condition, which means the stack should not be full. If the stack is full, means we cannot insert an element into the stack. So the first condition I'm checking for overflow condition. It is top is greater than or equal to n-1. So what is the value? Top value is -1. I'll check whether -1 is greater than or equal to 4. Why 4 is n value is 5, so 5 minus 1, which is 4. So the condition is false, so I'll enter into the else part. So into the else part, what we have to do first is I have to increment the top value. I'll increment the top value -1. So my top value will be 0 now. Then I'll insert stack of 0 is equal to value. So stack of 0, I'm inserting 5. So again, if I'm calling the push, means what happens? First again, I'll check for the overflow condition. So now the top value is 0. I'll check for the 0 is greater than or equal to 4. No, the condition is false, so I'll enter into the next else part. So I'll increment the top value to be 1, and into the stack of 1 I'll insert the value. Now look into the last push. Here what happens is I have inserted all the elements, so my stack is full. Now let's check the condition is. So what is the top value? Is top value. Now if I'm trying to insert one more element, suppose if I'm calling push of 39, so what happens is so I'll check for the overflow condition. 4 is greater than or equal to 4. I guess 4 is equal to 4. So I'll print their overflow. Now let's see the peak operation. So what do you mean by peak operation? Peak operation is displaying the topmost element from the stack. That is called as peak operation. So obviously, if you want to display the topmost element, our stack should not be empty. If there is some value in the stack, means only we can display the topmost element. So first we have to check for the underflow condition. How to check the underflow condition is, so if there is no element in the stack, means what will be our top value is? Our top value will be -1. So I'm checking. If top is equal to -1, means I'll display as underflow. Else I'll put I is equal to stack of top, which means I have to display the topmost value, isn't it? So whatever value present in the stack of top. So look at the first picture. The top value is 0. So stack of 0. So stack of 0, I'm placing it in I. So which means stack of 0. What is the value available at stack of 0? 5. So 5, I'm saving it in the 5, and I'm displaying I is the element available at the top of the stack, which means output will be 5 is the element available at the top of the stack will be our output. The next operation is pop operation. So to perform pop operation also we have to check for the underflow condition, whether the stack is empty or not. So here what we are doing, else I'm saving the topmost element, I'm saving it in the array. So here what is the top value is? My top value is 4. So stack of 4. What is available at the stack of 4? 12 is available at the stack of 4. I'm saving 12 at EL, the memory location EL. Then I'm decrementing the top value. So as I told you in the previous video, a top pop means we are not deleting any value from the array. So what we do is we will just decrement the top value. So finally, if we are displaying, means how we will display up to the top value only we will display. So now if my top value is 3, means I'll display only 0, 1, 2, 3, 1, 2 and 3 values from the array. So just we are decrementing the top value. So now imagine this is my look at this pop, second pop. So here first pop, here I'm the pop off, I'm calling pop off. So now stack value becomes 3, isn't it? Now if I'm incrementing, if I'm inserting one more element, if I'm calling push of 31, means what happens? My top value becomes 4. It will plus, isn't it? Plus top value. So top value becomes 4, and into the stack of 4. Stack of 4 means this location. Into this location, I'll place 31. So 12 will be overwritten to 31. Nothing, the data is not going to be erased. So further, if you want to use that particular memory location, overriding will happen. sequence. So look at the code now. Now VL is equal to stack of top. So I'm saving the element. Finally, what I have to display is I have to my output should be as 12 is deleted from the is popped successfully. I have to display the output. The aim is to display the output like this. So I'm saving the topmost element from the stack. Then I'm decrementing the top value and displaying the particular element is deleted from the top. Now look at the display operation. So how to perform the right up display operation? Obviously, if you want to display means we should check for the overflow condition. If there is nothing in the stack means we cannot display sentence. So if the top is equal to -1 means we have to display as underflow. Sorry, not overflow, underflow. Now, else what we have to display from where we have to display is from the top value. I is equal to top from the top value. So reverse order we are displaying. Suppose if I want to print in from 0 also, if 0 also from 0 also I can print. So here I am printing from the reverse order 12, 34, 8 as like that I am printing. So from I is equal to top. So here top value is 4. So I will be equal to 4 to I greater than or equal to 0 up to 0th index. From 4th index to 0th index I am displaying. So I am incrementing here. Finally, I am incrementing and displaying the value. Okay. So thank you for watching the video.